for today we'll be talking about exponential decay, which is very similar to exponential growth. It's just going to go the other way. So I'm going to go through and start our recording. Now, anytime you have to do this, the easiest way to do it is with a t-table. And if you're never told the values, go through and use anything from -2 to 2. It makes it easy. So at this point, we've got to go through and actually find those. So if you think anything to the -2 means we're going to distribute it to both the 1 and the 2. And since they're both negative, they don't like where they're sitting, so we've got to flip it, which then gives us the 2 squared over 1 squared, which is the same thing as 4 over 1, which is our 4, right there. And we're going to repeat our process for each of our other 4 numbers. So we end up with 1/2 to the -1, giving us the value of 2. And then if you think, we also have 1/2 to the 0. Anything to the 0 power is going to give us 1. So that's an easy one. And then 1 and 2, it's not going to change anything. We just need to distribute a little bit and solve it out. So we're going to end up with 0.5 there. Decimals make it a little bit easier to graph. And then for it being squared, we end up with 1 squared over 2 squared, which is the same thing as 1/4, which has a decimal is 0.25. Once we have these values, let's go through and graph. Our x value is our value going across on the x-axis, and our y value is going to be going up and down. So here are our points. And then let's play connect the dots to draw our graph. We should start off really close down here, go through our points, and head on up. Then next, we got to talk about some characteristics. Your domain for exponential functions is always going to be from your farthest left to your farthest right, which in this case are the arrows. So it's going to be your infinities, your negative infinity to positive infinity, or in case you're lazy, you could write it down as that double-barred R, meaning all real numbers. Next thing is your range. As you can see, we have this line drawn right here, which coincidentally is going to be our asymptote. That's the line we're going to be getting really close to, but we're never going to touch it. So our range is always from that number to an infinity. And since we're going up, it's going to be going towards positive infinity. Now your x-intercept, as you're looking, we're never going to touch this line, so we're not going to have one. For our y-intercept, it does touch one place right there at 1. And this is just your generic form of an exponential decay function.